So, hello guys, my name is Max and welcome to this video today where we're going to create a simple Flappy Bird clone using Javascript and HTML, and we will create it so it also will work on both mobile and on desktop. So the first part of the series will be just us creating the actual game, and then I will do a second part as well where I show you how you can change the JavaScript, CSS and HTML to an APK or iOS app file, Android or iOS app file using the Lulay cocoonjs framework that I have sort of looked into how it worked and stuff like that. But let's get started with the first part of the series. That will just be the creation of the actual game. So to start off, just if you want to follow this tutorial, just go to my GitHub page, and in my YouTube tutorial repository and in the Flappy folder here you can see a starter folder with just some starter files for this particular project, and that just include an index file with some basic metadata that sets the viewport and actually say that this is a web app, and some styling as well. And we also have this sheet image with the basic graphics for the game, and a sprite file that just sort of load all of the sprites in the sprite sheet for us. And I just do this manually, so yeah, and I thought that wouldn't be so fun to watch, so I just put that into the start file. Anyway, let's get started coding our game now then. So for this time, I will use this sort of syntax where I specify the var keyword up here, and then I can say canvas, context, width and height and stuff like that. That will be inside, all that will be prepended with this var keyword here. So these are all variables like so. And we'll also need some variables here that will set to 0 at the start. So our frames variable, a score variable, and a best variable that will be set to 0. And then we'll use a state machine in this sort of the same way we did in the Astro game, but not as big. So we just take the current state here, and we have the states object here. So we have the splash state, and I'll set that to 0. The game state set that to 1, and then we have the score state that we set to 2, like so. Then we of course need a bird, so we say bird, and that's also an empty object for now, and then the pipes object like so. And here we can actually close off the variables that we declared like that. So we will also need some game functions here, so we have a main function, run function, and update function like so, and lastly a render or draw function like so. And in that area, just make sure it's all the main functions so the game actually starts here. Let's just space it out a bit like so, and we can start with the main file for now. So we set the canvas, create it, so we say document.create elements canvas like so, and let's set the width to the width of the window, so say window.innerWidth like so, and the height to the inner height of the window, so say window.innerHeight. Then we can say here to check if it's a mobile device, that probably means that the width is less than let's say 500 pixels. So if the screen size is below 500 pixels, then we can be pretty certain that it is mobile we are dealing with. So then we have set the width to, let's say, 320 pixels and the height to 4. Oh, sorry, this should be bigger than 500 pixels. So if it is a desktop, that is, sorry, I got that the wrong way. So this is just to set a basic size for the canvas when we are inside of a desktop environment. And we can also set some styling here while we are on a desktop. So let's set a border style. So you say canvas style border, and we set 1 pixel, let's say solid, and let's say black for the color, like that. Now we just set the width to the width and the height of the canvas here, like so, and grab the context. We say context equals canvas, get context 2D, like so, and let's append that. Append the canvas to the body of the document. The document of body.append child canvas. So for now, if we just open this up in a browser, we should see the canvas drawn for us in the middle of the screen. So that's good. But let's open up the console to add some debugging later on. We'll probably get something wrong doing this game. But anyway, let's continue. So after we have appended the canvas to the document, let's create this image object here. That'll just be equal to a new image. That's of course the sheet image here that we're going to load. So say image on load, sorry, should be a dot on load here. So that equals to a function like so. Let's just set the source here before we do anything else. So say res sheet.png, like that. And let's just log out the message to see if it's actually our loading. Yeah, so the image are loading, at least the test message is written out. So when the image are loading, we just want to call this init sprites method that is in this sprite.js file that we include here in the head of the html5. So let's just call that, and let's call the run method. And as a parameter, this took the image object, so or the image object with all of the with the graphics we're going to use. So let's here this image parameter there. So let's just say you can say this here, since this is pointed towards this object, which is of course the image we are interested in, like that. So let's do a loop function real quick. So inside of here, sort that, we will just call the updates and the render methods or render functions. And then we use window request animation frame for our looping here. So say with the loop and the canvas as arguments there, like so. And let's just draw one of the sprites to the canvas real quick. So you can say let's draw the background image. So we can say BG, so S is just means that it's a sprite. I just use that convention here, and all of the names are here. So the bird sprite, that's actually a list of 3 sprites, all of the different frames, and then we have the background sprite, foreground sprite, the pipe sprites, some text, a text object with all of the text sprites, and so on and so forth. Anyway, let's draw the background. So we say s.bg.draw, and that took the context and a position and way to draw it. So let's draw that 0, 0 now. Hopefully now, yeah, it seemed to work. So we have the background drawn, but we want it to be drawn down here. So for doing that, we just take the Y position here. We take the height minus the height of the background sprite. Yeah, so now it is down here, but as you can see, we miss a bit here to the right. So let's draw one more background, like so, but this time let's offset it from the left by the width of the background sprite. So now we have the complete sprite drawn like that. But we probably don't want a white background, so to do that, I just took the background color here and save that to the background as well, so as an additional property here to the background. So we can just say context.fillStyle equals, actually we can do that inside of here. So here we can say context.fillStyle equal to the bg.color, like that. So we have that done, and then we just fill the complete canvas with we draw a fill rectangle on the complete canvas. So we say 0, 0, and the width and the height feels like so. And that didn't really work, so let's see what that can be about. Let's drag it up here and see if that works. Oh, sorry, it isn't initialized, so we need to have it below here, below the init sprites method. So now it should work. Yeah, so now the background is drawn as well. So let's draw the foreground real quick, or let's draw the foreground I should say. So s.fg.draw, and that will speak to the context, and that's 0 for now at least, and that's the height minus the height of the foreground, so that should draw it like that. And then of course the same cost as above here, we just offset our second one with the width of the foreground like that, so we have that done. So that's cool, but we probably don't want it to be drawn at 0 at all times. We want the position to be updated here. So let's create this foreground position. Actually, we can save it. Yeah, let's call it f foreground pos, like that, and let's have it here as well. So we have foreground position plus the offset, like that. And let's create that variable on the top here as well. So we have the foreground position, so foreground pos, and let's set that to 0 at the start as well. And then the update, we just update the foreground position. So you say foreground position plus equals, and here we say frames modulus some constant here. Well, actually no, we do not. So we say foreground position plus you can say equals, actually equals foreground position plus 2, and then modulus some constant here that we will figure out. I just said 10 for now, but we should actually increment the frames each update here, so do that as well. Anyway, so for now the foreground should be moving, yeah, but it's moving in the wrong direction, and I think 10 here is a bit too small, so let's try 12. See what that looks like. A bit jerky as well. Let's try 14. Yeah, so 14 seems to be the right modulus there for you, and you can see that it runs smoothly across the bottom of the canvas. So that's cool. So we now have the basic background drawn. So let's draw the bird now. So that's simple enough. But we of course first need to create these objects here. So we have an update method like so, and we have a draw method as well. And we can on that we will also have on both of the pipes and the bird. But we will start with the bird here. So we have an X position, and that won't actually change, but I will set that to 80 for now. A Y position, let's set that to 0. At least for now. And then we'll have a we'll have a frame variable of which sprite it's going to draw. So it's called frame. And then we'll have an animation sequence, and this is which order all of the sprites are going to be drawn. So the first, and if you look here on the sheet image, it have 3 sprites. So we want to draw the first sprite once, and then the second sprite, and the third sprite, and the second sprite again, and then start with the first again. So we can say 0, 1, 2, 1, like that, to get the animation sequence that we are. The animation sequence. Sorry, like that. Then we'll also have a rotation, and we'll set that to 0 at the start here, and a gravity variable here. So. And the gravity of what the bird is, yeah, which is affecting the bird, like that. And then it also have a jump variable here. So each time we press down, so how much the bird actually will jump up, like that. And speaking of jump, we also have a jump method that we will call outside of the bird. And in here. We can actually do that first here, so we just say this.velocity that I actually didn't create. Anyway, velocity, and that's just equal to minus the jump constant, like so. So let's just set the velocity here as well, and let's set it to 0 at the start. So, but let's but first, before we do anything in the update though, let's just create the draw function to see if we can draw the sprites. And let's say that it take a context as a parameter, like that, and then we just draw the sprite. And for this one, since we are going to rotate the sprite, we will use the context save and restore methods. The translate and rotate method of the canvas rendering context to these. So we say context.translate, and it is actually, so we actually translate the complete coordinate system using this method. So we say context.translate, and let's translate it to the x and y positions. So say this on x and this on y, like so. And then let's rotate the context. So say this dot rotation, and then let's draw the image. So say context of draw image. Also, sorry, we should draw the canvas. So we say or the bird sprite. So we say s bird dot draw, like that, and with the context like that, and then we say half of the width of the bird for the x position, and half of the width, half of the height of the bird for the for the y position, like that. And as I said, the bird is this list of sprites, like that. So we will of course need to specify which frames we're going to draw, and here we will say this dot frame, and this is of course this index up here. So that's it for the draw function of the bird. So let's see if it works. So we can just go down here below actually above the foreground layer, and we can say bird dot draw to the context, like so. So let's see if it's drawn. Well, it wasn't drawn really, so let's see what that can be about. So let's try to just set 100 here for the y position. Nope. 1 second guys, and I'll debug it, then I'll be back. Yeah, and I figured out the error here. This of course is a null error here, since we are just saying s.bird dot the width and the dot height. We of course need to say which an index here as well. So for that, let's actually use this n field here. So that we said it's up here, so we say that's just equal to this dot animation, and this dot frame, like that, to get the right animation frame that we are interested in. And up to now, the bird should be drawn to the canvas. Yeah, and here you can see that the bird is drawn. So let's make the position update a bit here. So for that, we'll use this sort of in the update method. We can say here, we can say, let's just say, let's check if the current state here. So say if the current state is the states dot splash. So in the splash, we want the bird to flap with a lower frequency than we want to do when it's in the game state. So we can say if the current state is the splash state, let's actually set the current state to the splash states in the main method. So down here, so let's just set the current state. So say current state equals states dot splash, like that. So now this n field here should have 10 in it, and then we'll set the frame. Increment the frame here. If the frames modulus, this n constant here, is equal to 0, then we want to increment it. Else we just want to keep it at the current frame. And then so we loop over over what do you say? So we start from the start when the frame is when we are going to the end here. So we say we just modulate this the length of the animation sequence. So they say this dot length. So this is the animation dot length, and of course we don't call the update method. So let's do it. So we say bird.update, and let's actually call the pipe.update here as well, and the pipe.draw down here with the context as a parameter. Yeah, so now you can see that the bird is flapping, or yeah, whatever that's called. So that's cool. So yeah, so let's update the position a bit, and we can do that here in the update method as well. So you just can say what do you say? We check if the current state again is the splash state. So we say state dot splash, and then we just set the y position to the height minus some constant here. So let's say 270 or yeah 280 maybe, and then we can say plus 5 times math dot not meta math dot cosinus of the frames field of frames variable divided by some constant here to ease it out a bit. And let's just set the rotation here as well to 0 when we add it here. So now the bird should be moving up and down like that. Just one second, guys. Be right back. Yeah, sorry for that, guys. I'm back. So yeah, we now have the bird drawn to the canvas as well. But we will want some more stuff to be drawn to the canvas when we are doing the when we are in the splash state. And just one small tweak here. I think the bird is a bit far to the right here, so let's just say 60 instead here. Yeah, I think that's better. Anyway, so we go down to random method again. Down here we can say let's say here after we have drawn the pipes and the bird, actually can do it all the way down here. So we say if the current state again is the splash state, so we say states.splash like that. Then we want to draw the splash screen, so we say s.splash and .draw like that, and to the canvas of course. And then we want to center it in both directions, so we say let's just calculate the center of the canvas here first. So say width 2 equals to the width over 2 like that. Now we can say width 2 minus the height of the splash screen sprite. So we say width like so. And for the x position, so for y position, let's set height minus 300, and let's see what that looks like. Yeah, so that's the what do you say? That sprite drawn to the canvas. Then we also want to draw a text to the canvas, so we say text.draw to the context again, and then we say width 2 minus and of course we want to specify which text we want to draw here. And as you can see here, the text is have this sort of JavaScript object, so we will draw the get ready message. So it's say just text s.text dot get ready dot draw like that, and then we want to have the width of that text again, so we will just say it like so, and then the height minus some constant here. Let's say minus 380. Let's see what that looks like. Yeah. So that's all for the splash state. So let's do the game state now. So yeah, that's quite simple. We of course need to, first of all, we'll need to have a mean to transition between different states. And so for that we just have this onPress method here, so we say function onPress like that, and that will take a event here as a parameter. And inside of here we just do a switch of the current state. All the cases here, so are the cases states dot splash, case states dot game, of course, and we have this states dot score, I think we call it, yeah. And here we just call it break for now, like that. So we have that on. So when we are pressing and the current state is the splash state, then we want to set the current state to the game state. So we say states game, like that. And we also want to make the bird jump. So we say bird.jump, like that. In the game state, we only want the bird to be jumping, so we say bird.jump, like that. And in the score state, it's a bit more complicated, so we will leave that empty for now, at least. But we haven't set this method to any event yet, so let's do that. So if it is a web browser, then we want to listen for the mouse down event, so we say add event listener. We can actually do it like this, so we say bar event equals, also we can call it edt, like that, and we set that to touch, so like this, touch start at in the normal case here. But if it is the web browser, then we say mouse down, like that, and then we just add an event listener, so we say document.add event listener, like so, and we will listen for the event, and we want to call the onPress method when we are calling this. So up to now, when we click on the we have some errors here, so we say add event list. Let's try again. Yeah. So now when we click on the canvas, this background, the splash screen should be removed. Yeah, and that seems to be the case here. And as you could see, the bird is actually flapping a lot quicker now. But we haven't done any updating of the bird in the other than in the splash case. So let's do that. So let's just go back up to the update method, and here we can say else here. So if it's not the current state, if the current state is not the splash state, then we want to update the bird normally here. So we have saved this dot velocity, add a gravity constant to the velocity, yeah, like that, and this should of course be this. Then we add the velocity to the y position, say this dot velocity, like so. Then we check some errors here, so we check if the y position is bigger than the height of the position of the foreground, so we say like that, and let's say -10 for some offsets here. Then we just want to set the y position to the height, to the same position here, so we say f height -10, like that. I don't know why I misspelled this all the time here today. Anyway, and if this is the case, then we also want to make sure that we set the current state to the score state if it's not already, if it isn't already the score state. So you say current state equals states dot score state, like that, and then we'll set the velocity here to the jump speed here, just so this velocity here won't grow out of hand here. Anyway, so we have this done. So then we just check here we will do the rotation. Or actually, we can see what it looks like now. So now you can see here that the bird is jumping like this, but we also want to implement the rotation. So let's do that. So for doing that, we'll say if the velocity is bigger than the jump speed, or equals to the jump speed, then we want to set the frame to 1, so we don't want the bird to flap anymore. And then we set the rotation fill here to the minimum value between the mat over dot pi over 2, so the maximum angle can only be 90 degrees, like that, or the rotation plus some constant here, so let's say 0.3 or something like that. And else, so if the speed is, if the bird has some upward momentum, then we want to set the rotation to, let's say, negative 0.3 maybe. So let's see what that looks like. Let's reload it, and yeah, now we can see that the bird is actually rotating like that, and that it's, yeah, when it's below a certain velocity here, that it dive like that, and then we have the game over state like that. But when we are game over, we probably don't want to update the foreground position, so let's fix that real quick. So let's go down to the update method, and here we can say if the current state is not equal to the states dot score, then we want to update the foreground position. So let's see if it works. So bam, yeah, now that is done at least. And the same goes for pipes. We don't want to update the pipes position when we don't have the when we aren't in the score state. Or actually, we only want to update the pipes when we are in the menu in the game state. So we do it like this instead. So say when the current state is the game state, then we want to update the pipes. So we say pipes.update, like that. Speaking of the pipes, let's do those real quick. So the pipes, we only have one in members here, a pipes list like that, and we'll also have a reset method where we just clear the pipes. What do you say? The pipes array here. So you set the list of pipes to an empty array, like that. So let's do the draw function first, maybe. Yeah. Or maybe let's do the update actually. So here we can say if the frames modulus, let's say 100, so each 100 frames, or 100 pixels in this case, we will push a new pipe to the pipes array. And the position of the pipe and stuff like that's a bit yeah, arbitrary to set there, but sorry. So we have set the top position here. Let's set that to the height minus the height of one of the pipes. It doesn't really matter since both the south facing pipe and the north facing pipe are both 200 pixels tall like that, so actually 400 pixels, since we are multiplying the width and the x and y position share by 2. But anyway, so the height of the pipe, like that, I think, yeah, plus the foreground height, the height of the foreground, yeah. So this is just where, this is the y position where I want the pipes to be drawn. So let's actually call it y, like that. And then plus some constant here, let's say 120, and plus the random position here, so say 200 times math.random. So this is just to set the y position randomly within the border of the game. And then we just append a new object here to the pipes array. So we say this.pipes.push, like that. And let's set an X position, and let's set that to something outside of the canvas. So let's say 500. And then set the Y position to the Y field we just created. Or calculated, sorry. And let's also set a width and a height here later when we're doing our collision detection. Not just the the width of the pipes, and the height here, of course, the height of the pipes. Like that. So that's it for the creation of new pipes. Then we just update all the pipes. So we say for var I equals 0, len equals this.pipes.length. Like that, I is less than len, and then I plus plus, like so. And we just take out the current pipe, so we say this.pipes at I, like that, and then we just update the position. I think, yeah, so we say p.x plus equals, minus equals, since we're going to the left, like that, and then we just check here if the x position is less than, let's say, minus 50 here, so if it's outside of the canvas, then we want to remove that pipe from the pipe array. So we say this.pipes.splice at I, and we want to splice one object, and then we just want to decrement the length and the I fields, like so. So that should be it for the pipes, at least for now, before we do any collision detection and stuff like that, which is quite important in Flappy Birds. But anyway, let's do the draw method. So we can just copy this for loop here, since we don't want to type it all the time. And inside here we just take out the current pipe here. So pipe this.var p equals this.pipes at I. And then we want to draw it, so we say spipe south.draw, like that. Then we draw to the context and a p.x and p.y position. And we want to draw the north facing sprite pipe as well, so you say north, like that. And for the Y position here, we just want to add the gap between the two pipes, so let's say 80 pixels plus the height of the pipe, like that. So for now we should see the pipes drawn to the canvas if we have done this correctly. And that seems not to be the case here, so I will just debug this really quick, guys, and I see when I'm back. Yeah, I'm so stupid, I didn't really even realize it. I've written all of this in the reset function and not in the draw function. Shit, that's so stupid. Anyway, I just added it to the draw function, and let's see now if it works. And it still doesn't work, so bear with me, guys, I'll be right back. Yeah, and I still had the empty of the pipes there. I'm so stupid. Let's see now if it works then. Yeah, so now you can see that the pipes are drawn. Sorry for that, guys. I'm so stupid. Yeah. So we are closing up to the end here. At least of the first video of this. This was a bit longer than I expected, and I have other things to do today. So I will actually split it up in 2, maybe 3 videos. So yeah. But let's just finish the collision detection, so we have that done at least, and then we'll finish the rest of the game in another video. So let's do that. So let's just go up here again to the update method, and the collision detection we are going to use here is a circle rectangle collision. This can be a bit complicated, but yeah, it's pretty straightforward. But anyway, we check here, we say if I is equal to 0, so if it is the front most pipe, that's the one we want to check collision against, then we use this, then we calculate the closest X position using this clamp snippet here that we have used in many other tutorials, like like the restriction of the, what do you say, the pedals in the Pong game and stuff like that. Anyway, and the values we want to check against is the x position of the bird, the pipe position and the x direction, and the maximum, the x position of the pipe here plus the width of the pipe, like so. Then we have two y positions to calculate here, so you say math, so we clamp again here, so you say clamp like that, and we say bird.y, p.y like that, and we have p.y plus p.height like that, and this should be the, what do you say, the south facing pipe. Then we have the other one, so you say clamp again here, and for the values this time we do we want to check against the y position, of course, still, and we have the p.y plus the p.height plus 80, since the offset is 80, I think. Did we do that in the draw method? Yeah, so 80 here is the offset. And for the max position, that is of course just equals p.y plus 2 times p.height plus 80, like that. And that should give us the closest positions, like that. And then we want to do two checks here. But first we want to check the difference in the x and y positions here. So you say bird.x minus the closest x position. And then we have two y positions again to check against. So you say bird.y minus cy1. And the same here for the delta 2 position here. So you say cy2, like that. And then we have the two distance here. So yeah, and this is sort of the equation for a circle. We are of Pythagoras theorem we are using here, but anyway, so I have the distance 1, and that's just dx times dx plus dy1, sorry, plus dy1 times dy1, like that. Then we just change this to 2's here, like that. So we have that done. And then we just want to return here. So you say bird.radius. Actually, we can call r here first to say r equals bird.radius times bird.radius. We don't have this radius field yet, but we'll soon add it. And we want to return if r is bigger than d1 or r is bigger than d2, like that. Then we want to set the current state to the score state. That means that the bird has been hit. So let's just do this radius field on the bird real quick. So we say radius for the collision circle here, and let's set that to, let's try some different there. So let's try 12 for now, and just so we can see the how do you say, the circle for now. Let's just draw it out to the context of begin path here, sorry, and the context of stroke, like that, and then we'll say context.arc. I think that's the method. Anyway, we will soon see 0, 0, and this the radius here, and then between which angles we want to create here. So say 2 times math of pi to get a complete 360 degrees, of course. Let's see if it works. Yeah, so you can see that the bounding box of the bird is drawn a bit subtle, and yeah, you can see if when we hit the pipe, the bird is dying. So let's do it like below here instead, I think, and let's draw it with the fill. Yeah. Anyway, let's just set the fill style as well, so just so we can see it. Just so we can see it here. So you say context of fill style, let's set it to red. So you can see it. Yeah. So you can see that's the collision we are going. That we are the bounding box of the bird. Yeah. And you can see that the game is as annoying as it is on the mobile phone. Anyway, so I think that's it for this video. So I thank you for watching, guys, and I hope I see you in the next video. Yeah, so that's it. There's one thing though. Let's just draw the, what do you say? Let's draw the bird in front of the pipes. I think that looks a bit better while we are dying here, so let's test that. Yeah, so that's it. Thanks for watching. Bye. So, hello guys, my name is Max and welcome to this video today. We're going to finish the creation of our Flappy Bird clone. I just want to start to apologize for the lack of content during the last few weeks, but I've been busy creating other stuff and haven't had time to upload any videos. And hopefully from now on, I will continue to upload weekly videos. But anyway, without any further ado, let's continue with our Flappy Bird game. So, where we lost last time, we just got the basic, so to speak, splash state and game state going. So we got this message here, and then we can press on the screen, or on the canvas rather, and the bird jumps like this. We can move between pipes and stuff like that, but when we got hits, yeah, the bird dies and stuff like that. So today, we're mainly going to implement the score state, and wrap this game up, and then port it using cocoonjs to Android, or Android. I don't know how to pronounce that in English, but anyway. Yeah, so let's go into our project here. This index file and the spray.js file that we had in the previous video. And yeah, so today we're going to use fields like here. We want to use the text field, the score field here, or the variables rather. And we have the game over text and stuff like that. Yeah, so let's start by drawing those to the canvas maybe. So you can just go all the way down here to the random method. And after here we have checked if the game state is the splash state. We can check if the state is the, what do you say, the score state. If it is, then we basically also want to draw the game over text to the canvas. So we say game over draw like that, and we draw to the context of course. And we take this half of the width of the window, so width 2 here, minus the half of the width of the game over text. So they should be like this. The width, of course, divided by 2, like that. And then I've checked these positions earlier here today, but so the height minus 400 pixels is pretty good for the Y position. So let's see what that looks like. Yeah, so now I have the game over text written out. But we also want to have this sort of the scoreboard drawn as well. So we just can just copy this line down. It's pretty similar, I think. So instead of score text here, s underscore text and stuff like that, we want to draw the score sprite, and the same. And instead of the width of the game over text, we want to have the width of the same sprite. That is. And for the Y position, take the height minus 340 pixels. And that should look something like this. Yeah, that looks pretty good. And we also want to draw this sort of OK button down here so we can press to continue to the next state and stuff like that. But we won't draw it here in the same way as we have done here, since we need to check later if our mouse press is inside of that particular button or that OK button. Then it's better to create this sort of object where we with the button. So we can go all the way up here, I guess over the bird, something like that, and let's create this OK button object, like so. And here it will need an X position. That will of course be, so we can't actually instantiate it up here, so we just create a variable here, then we'll actually instantiate it here down here in the main method. since we'll need to use the width and stuff like that, and we haven't instantiated it until we have called the main method, yeah, then we need to instantiate it or initialize down in the main method function order. Anyway, so we just go down here after we have set the fill style, and yeah, down here we can set the OK button to a new object. Yeah, so flat. Anyway, so the X position, that will just be the width. Can do it like this time. Width minus the width of the, I think we call it something like, yeah, the width of this sprite here, the OK sprite. So S buttons OK, like that, OK. So width here, and then just divide that by 2 to center it. And the Y position, let's take the height minus 200 pixels. And then we also need a width, and that's just the width of the OK button, like that. And then we also have the height here, so that is OK the height, like that. So I have that done, and then let's just draw it. So we go down after here, we draw the scoreboard sprite, and we just call buttons OK.draw, like that. And we want to draw to the context, of course. We want to draw it on the OK button.x position and OK button.y position. So let's see what that looks like, if it works. Yeah, so we have that done. So that's cool. And yeah, so now basically we can check if we press on the button. And to do that, we go up here again to the onPress function. And here where we check if the switch statement, and where we check if this is the score state, then we basically just want to take out the mouse position or the click position, and check if that is inside of the OK button. So the X position, we can just take the event.offset X position, and for the Y position we take event.offset Y, like that. And this will work in most of the browsers. I don't think it will work in Firefox, since they have something like layer X and layer Y instead. So if you're on Firefox, just to make sure that you say layer here instead. So this is probably not that good method to only use like this to figure out the position. We should probably use some more foolproof way, and a link to this post will be in the description. But anyway, this guy here have figured out this sort of function where we can calculate the mouse position. And here we say that layer XY is deprecated in WebKit, but Firefox doesn't even have offsets X and Y. Anyway, so that makes stuff like this a bit stupid and hard to figure out how it should be. But I'm Chrome, so I will just use offset X and Y during this simple clone or something like that. Anyway, and then we just check if MX or MI is inside, if the X and Y position is inside of the OK button. So we say if OK button dot X is smaller than MX, and MX is smaller than OK button dot X plus OK button dot width, like that. Then we also need to check the Y position, of course. So MY, and MY is smaller than OK button dot Y plus OK button dot height, like that. Then we just want to reset the pipes, as you say, pipes dot reset, I think. Yep. And we also want to sort of set the current state to the splash state. So you say states.splash, like that. And yeah. And we also want to set the score here to 0, of course. We haven't incremented the score yet, but anyway, we want to make sure that we set it to 0 when we go back to the splash state. Yeah, so if we just save this and reload it, the pipe shouldn't be resetted, but because I think we have missed that implemented that method. But if I just die here, you can see that I can press OK, and we come to this state at least. Yeah, and then we should all we will die all the time here. Anyway, so let's just implement this reset method here, and that's pretty simple. We just want to empty the pipes array like that, and let's see if that works now. Yeah, so that's it. Yeah, so that's actually almost the complete game there. The final thing to do is perhaps to implement the score, or display the score. Yeah, so let's do that. We can start by incrementing the score. We can just do it right here, I guess. Yeah, that's good. So you can just say if, I can just actually say it like this, score plus equals. You can use this turn operator here, and then we just check if the pipe's x position is the same as the bird's x position. They want to increment it with 1, else we want to increment it with 0, or not increment it at all, that is. So the score is now updated each time we go through our pipes. Then let's just draw it. So we want to draw the score right here each time, or in both the splash state and in the in the game state, but not in the score state. So we can just state an else statement right here, and then we just have a number. I think I called it like that. Yep. So I have the small numbers, and we have the big numbers. And if you look in the spreadsheet here, this is of course the big numbers, and this is the small numbers here. And I just implemented this simple method here where we can draw the numbers to the canvas. Yeah, so let's just use let's use this method with the big score, I think, to draw the first score here, or the score in the splash state and the game state. So we just take like that. Then for the x position, let's just take the width 2 for now, and for the y position let's say 20, and for the number we want to draw the score, of course. And oh yeah, I think that's it. And I also think we need the context to draw the numbers. Yeah, so now we have the score drawn up there, and now when we pass through the pipes, I should hopefully increment. Yeah, you can see that it goes up like that. Well, as you can see, it isn't very centered. We want to center it in the middle of the canvas. So let's do that. So to do that, we can just add an additional field here. We can call it center, like that. And then down here we can just say if center, then we want to set x position to the center. Yeah. What should be minus or plus here? Yeah, minus, I think. Yeah, minus. Minus the length of the number string. So number.length like that. Times the step size actually. So we need to instantiate the step size before we recalculate the x position. Like that. And we also want to subtract 2 pixels here, since yeah, you can figure that out by yourself, but we want to only have the width of the last letter, not the actual padding width. So that's why we subtract 2 from the step size there, or from the actual x position. So you can see if that works. So instead of the x position here, we can say null or something like that. And then we just take the center position, so that's the width 2. The implementation we have done. So the text should now be completely centered. Let's just see if I can get over 10 score here. I don't think I can do that, so let's just go like 100 and see what that looks like. well, it's not really. Oh, I forgot. We need to, of course. We want to, of course, divide this by 2. That's so stupid. And then we also want to. Boom, 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 boom. Yeah, we want to do it like this. We want to subtract 2 right here. Then we want to divide it by 2. Like that. Let's see it now. Yeah. Now it's completely centered in the middle of the canvas. Cool. Let's go back to the score field here. And yeah, so the final thing to do is just to draw the small score numbers on top of the scoreboard sprite. So for that, as I said, I have figured out these coordinates before here. So for X position, and that will be the width 2 minus 47, and that took some trial and error to figure out that number. And for Y position, take the height minus 304 pixels, and we want to draw the score text, of course, like that. And we don't want to center it, but we want to pad it by 10, or offset it by 10. And what that is will be clear in a moment here. And then we also want to draw the best score, and that position we want to set to the Y height minus 262 pixels. But as you can see, I added this fifth field, like thing. Oh, sorry, sixth field augment to the function, and that is the offset. And that is the same principle as we have in the Astro game. So if we have the specifier on offset, we just set like this. And we want to add the step size times the length of the num string times the step size, like that. Minus 2 again, I think. Let's see what that looks like. Yeah, it looks right, at least I think that. So let's see what it will look like. Well, no. Oh, of course, I'm so stupid. We of course want to subtract, and I don't know why I multiply that by the step. Oh, that's so stupid. But we of course want to have the offset here minus the length of the num string. Hopefully now it will work if we go back to 10. Yeah, we did that, so let's just see what it will look like. Yeah, so that's good. So that's it. That's almost the final game. We show the final thing here. Let's just update the best field as well here. So as you can see, best is always 0 here, but we want to set that to to the score if it is higher than the current best value, so to speak. So to do that, we can just go up to the update method, and this is quite bad way to do it, but anyway, we just want to check if it is the score state, but we already do up here actually. So anyway, oh, not. Oh. We can say else then. Then we just want to set the best field to the maximum value between the best with the current best value and the score value. So that's it for this very simple demo. Yeah, so you can of course add some more fancy things to the game, like menu state and other stuff like that. As I said, I did figure out the position of all of the numbers and stuff like that earlier today, and I also made this sort of exact this version here, but I added animation between the different states. to make it look a bit more finished. And I won't go through it right here, and the code is really messy, but you can see if you add like some animation, that will make the game look a lot better, like this. And it's quite easy to implement this. Just Google for tweening effects, and you should be able to make something similar to this. But for our version, we will only use this sort of very basic graphics graphical version like this. Yeah, so that's it, guys. We now have the finished game. So let's jump up to mobile and let's port this to Android. So see you in a moment, guys. Oh, just one thing, guys. We need to implement the support for touches, or to get the coordinates from touches as well. Not and that isn't the same way as we have done in the with the mouse actually. So let's go back up here to the unpress method, and just below here we set the mx and y variables. We'll just make this simple error checking here, so say check if the mx is null or my is null, like that. Then we want to set the mx position to the event.touches, the first touches, so 0, and the client x position, since it will actually fill the complete canvas there, and y here for the y position. So for now, if we just reload the reload this, yeah, we won't get any errors, so that's been set. It works at least. So yeah, let's jump over to mobile. Before we do that though, to make stuff a bit simpler, I will start a HTTP server with this project in it, so we can do some testing later on here. So you just go to wherever you have saved your file. So if you're not that good with terminal commands, then you just find your file. So you say Flappy, like that. Then you can just cd, press a space. Don't forget the space, guys, and then pull in the folder you want. You have your project in. Press enter, and that will take you directly to that folder. And then you can, if you have Python installed or Node installed, I have Node, so I've used a simple Node server here. And if you want to install, and this is just HTTP server like that. And if you want to install that, just install Node. You go to nodejs.org and install Node for your platform. And then you can open a terminal and write sudo in npm install g http server, like that. Press enter, type in your password, and that will install this HTTP server for you. Anyway, so I have this up there, so cheap works. Just go to localhost and the port, and yeah, it shouldn't be any changes, but we now can check the application on the mobile as well, if you're on the same Wi-Fi network as your computer on. Anyway, that's it, guys. Let's jump over to mobile now. Yeah, so we are now on my mobile. So let's check if this game actually works. And if you, in the bad frame rate, and this recording is of course because I record this video in the same time as I show you this, guys. So anyway, the first thing to maybe do is to just open up a web browser. I use Chrome for this particular example, and then go to the router address of your computer on your Wi-Fi network. In my case, that's 192.168.0.11 and the port 880, like that. And if you go to that address and I've set it up the HTTP server the way I did before here, you should be able to test the game on your phone as well, in the browser. And as you can see, they're real bad frame rate here, of course, because I record. One thing that's quite cool though, is because we have set up the metadata the way we did in the index page, and we can add this to the home screen and as a web application. And when we do that and open it, it will have this real boring graphics now, since we haven't what do you say, any icon data or something like that. But you can open it up as a web application, and as you can see, we now don't have the URL bar or anything like that, and that should work on both iOS and on Android. As you can see, it looks quite well, good as a regular web application like this. But we want to port this to an actual app file. So in order to do that, let's just close this down. Go to the Play Store or App Store if you are on iOS, and just search for cocoonjs, since that's what we're going to use in order to build or compile our application. So just go to the install the launcher application, and I already have mine installed, but I want to update to the latest version, because there's some down here some claim that the newest version doesn't work and stuff like that. So anyway, so just install that to your phone, and you can test how the application will look like when after you have compiled it. It will take a while for it to start, maybe a bit longer than usual, because I'm recording. Yeah, now it seems to be working here. So let's see. Yeah, so just go to your app here, and you can test it inside of their launcher as well. So just go to the address, and don't forget the http:// in order for this to work here, and just launch it as a canvas application like this. And you can see here I got real bad frame rate now since I'm recording, but otherwise you will get 60 frames a second, no problem. We could of course make this a bit better by implementing some sort of delta timing and stuff like that, but we haven't bothered with that in this series. But anyway, so now when you have tested it on all of those platforms, you know that that game actually works. So let's go back to browser and compile the iOS application, or sorry, the Android application. See you on the desktop, guys. Yeah, so guys, we are now back on the desktop, and let's actually compile our application. So it's quite easy. Just go to Google or whatever and search for Luday and cocoonjs like that, and it should be the top link. And when you are not signed in, it looks something like this. And I should have said this before, but you of course need to sign up in order to use the launcher application and other stuff like that. So just make a simple user here. I think you can figure it out by yourself, and then sign in to the dev portal. So I just sign in here, and it looks something like this. So you can go to the dev portal here, and here you have your different projects and stuff like that. So let's just delete the test project I did here, and stuff like that. So let's just create a new project, and you will be greeted by this page here. So here you can set an application name of the project. So for example, let's just use Flappy.js, and then for the bundle ID, you can use something, whatever you want here. It said that it need to be a unique identifier for the application, and yeah, they sort of have had this example here on our naming convention. So yeah, I just use that for the bundle ID. Now let's type out a version here. So let's say you have the release candidate 2 version here, like that. This can of course call whatever version you want here, and here you say which modes the app should be supported, and we can support both portrait and the portrait upside down, for example. And you choose how we want to scale the application, and it doesn't really matter in our case here since we have the canvas fill the complete screen, so we can just keep it at scale to fill settings like that. Then just press create project, and that should give you get you back to the projects list, or to directly to the compile section. So yeah, it just shows you. It's the same if you go to the dev portal and just press on your project right there. And here you set the general settings, and that was the things we did when we did the initial setup here. Then here you can go to all of the different the different configuration files for all of the different platforms that you can support here. So you need to set like the different launch images and stuff like for iOS and the app icon, of course. But yeah, we won't change that. We will just go for the regular versions here, and the same goes for Android. Here you have different sized icons and stuff like that. But anyway, the important thing to go to right here is go to the compile project section, or the compilation, and on the compilation section. And here you just want to upload, I should say, a zip file of the project. So just go to wherever you have saved your project. In our case, it should be right here, right? Just right click it. Actually, maybe we want to make it to a zip file first here. So let's just do that. So you right click on it, and you can say a compromise or whatever it's called. So just make it to a zip file like that. On Windows, I think it's something similar to this, but you can figure out how to make a zip file yourself, right? Anyway, so basically just choose the zip file, and you should upload it like that, and then you choose for which target platforms you want here. So let's say you want it for iOS and for Android. So just tick those two checkboxes, and then choose which sort of way you want to run the application, or run using whatever framework you want to run the application with. And I just use Canvas 2 here, and then you choose the compiler version, and I should go with beta version. I haven't had any problem with this, and I just tick the term, I accept the terms, blah blah blah, checkbox here, and then you can compile your project. And it will take some time, and then they will send you a message that your project have been compiled. And I have already compiled the project, so I won't do it again, but it's as simple as just ticking that box and press the compile project button. So then it would take a while, maybe 20 to 30 minutes or something like that. Maybe 10 to 30 minutes, I don't know the exact time frame here, but something like that. And then they should send you this email here where you can download your application. So yeah, so when we have downloaded that, you should get a folder or something like this after you unzip the zip file. And then here you have the different versions for all of your platforms. And as we did this README file here, that you can use, see if you can center that one as well. Yeah, you could, where it say how you run the different versions of the files inside of the zip file here. So if you are on iOS, it says that you can't run it in the emulator on the computer, but so in order to build it for iOS, you need to have both a Mac and an iPhone or something like that, and device running iOS. But since I don't have that, I will go with the Android version here. And as I say, we have two different Android versions. One that is signed with debug info, and yeah, so the debug version here is just for debugging purposes, and then the release version is the one you want to push to the apps to the Play Store when you release your application. Anyway, so from here it's quite simple, just to see if it works for your particular platform. So if you have Android, that's pretty simple. Just send yourself a new message like this. So, and yeah, and then you just what do you say? Put this file with sorry, and you just send one of the files to yourself. I don't think it matters if you take the debug ones version or the release version. It doesn't really matter. Just choose one and send it to yourself. And let's go back to my mobile file and let's see if we can run this. So see you in a moment, guys. Yeah, so we're now back on mobile. So let's see if we can install the application and see what it looks like when we run it. So it's really simple. It's just go to your email client. So I just go for Gmail this time, and then just go to the message that you send to yourself, and then just press the download button here. Yeah, and I've just downloaded it before here, by the way. So, and you will get this message here if you have set the settings that you can install application from unknown sources. So just press the install button. Hopefully it will work. No. Try again. Yeah, anyway, just press the install button and it will install. But I have already installed one version here, so I just go to wherever it will save, and just press the yeah, the app icon like that. And let's see if we will start here. Yeah, and you will get this powered by Luday splash screen. I think you can change that in the compilation. Yeah, in the project settings. But anyway, and here's the finished app. Yeah, and as usual, the bad frame is because we are recording. But other than that, the game is running really smooth when you aren't recording like that. And the version I compiled here is actually the one with the animations, but the process is similar for the other version as well. But anyway, guys, so this is the end of this video's tutorials, and I hope you've learned something watching these videos, and I hope I see you in the next videos. So, thank you guys for watching, and see you next time. Bye!